The last section we have on surface area is surface areas of spheres. Okay, so what's a sphere? Well, this is what it looks like, a ball. Okay, it is actually the locus of points contained in a three-dimensional universe that are equidistant from one point. Okay, think about that. You have one point, collect all of the points that are the same distance from that one point. What are you going to have? You're going to have the surface of a sphere. That's what a sphere is, a surface, okay? We think of it as a solid, not necessarily. A solid would be made up of a whole bunch of spheres that are concentric to each other, okay, occupying the same space. So this is a sphere, all right? That's what it looks like. Now, we have some definitions that we need to know in the sphere. Some of them we've seen in other areas, but we need to define them as for a sphere. Radius of a sphere, any segment connecting the center of the sphere and a point on the sphere. So that simply means if we could go in here and get the center of that sphere and connect that center to any point on the sphere, that would be the radius. Just like the radius of a circle is point that is the line segment that connects the center of the circle with any point on the circle. This is the same thing, okay? You'll notice that we start using this concept of the center of the sphere. Chord is a segment whose endpoints are points on the sphere. Any segment that has two endpoints that are on the sphere, on the surface of the sphere. Okay? Now, diameter is a special type of chord that contains the center of the sphere. Okay? Just like the diameter of a circle is a special chord that contains the center of the circle. The chord of a circle is any line segment whose endpoints are on the circle. Diameter of a circle is a chord who contains the center of the circle. Well, guess what? Diameter of a sphere is a chord that contains the center of the sphere. Tangent. Okay, remember what a tangent of a circle was? A line that intersects a circle at only one point. Guess what? Tangent of a sphere is a line that intersects that sphere in exactly one point. Okay, now here's some new ones. A great circle. A great circle is an intersection of the sphere and a plane. Okay, so sphere is a solid, a plane would be like a sheet of paper, and that intersection contains the center of the sphere. Okay, it would make a circle. So if we were to slice this thing down the center, contain the center of the sphere, we would make a circle. Okay? All right? We would have a circle. All right. I think I may have one of those I can show you. This right here. We sliced it. We diced it. Okay? All right? That right there would be considered a great circle. Okay? Why? Because it contains the center of, it's an intersection of the sphere and a plane, okay, that contains the center of the circle of the sphere. Okay? So that would be that. And the last one. Hemisphere is one half of a sphere. Now, we've already said that a great circle creates two hemispheres. So if we have a great circle, it would cut this in half. We would have two of these. Okay? Now, one of the interesting things to think about, so when we have a sphere, all we have is the surface of this round thing, okay? When we have a hemisphere, we have half of the round thing, but we also have the area of the circle. So when you're calculating surface area of hemispheres, don't forget you have a flat circle that you also have to include. We'll do that on some sample problems, okay? So a hemisphere is going to be half of the sphere plus the base of the circle, or the base of that hemisphere, which is going to be the area of that circle. Okay? All right, there's our definitions. Now we need to do some sample problems.